Woo! Continuing on with limits here, section 1.4, we're going to be finding limits from tables, but also algebraically. We're going to dive into that just a little bit. All right. So when we have a graph, we saw it's actually, it's pretty easy to see the limit of f of x as x approaches 3. So if we take this graph over here on the right, we can see that our limit is going to be, as x approaches 3 from the left and from the right, it's approaching 4 for my y value, right? So 4 is my answer. Now, what if we saw this as a table? Okay, so this, now we step down there, we use a table of values to figure it out as well. As our x values are approaching 3 right in there, right? We're getting 2.9, 2.99, and then from the right-hand side, we've got 3.1, then 3.01, even closer to 3. We can see that my f of x, my output, my y values are approaching 4. There we go. Now on that graph, it's a hole in the graph, right? It's not, there's no value there for, but it's approaching 4. So basic idea there of tables. Some of them will be maybe a little more challenging than others, but let's take a look here. How about number 1 here? According to the table, what is the value of the limit of f of x as x approaches negative 4? So as I'm getting to negative 4, which is right in between here, right from the left, I get negative 4.4, negative 4.001, and again, we'll just get closer and closer and closer from the left and from the right. What are we approaching there? Well, it looks like we are approaching 2.5. I think we'd all agree with that. Awesome. Now, what about if we're not just given a table, we could create our own actually. So let's do that. We're going to pop out our TI-84 Plus or TI-83 calculators. All right, so we want to find the limit as x approaches negative 2. The limit of f of x as x approaches negative 2. Now, why might that be a little bit challenging? Well, when we're looking at this here, if you remember anything about rationals, if I were to just directly plug in negative 2 for x, I'd be dividing by 0, right? That'd be no bueno there. So let's use a table of values. Now, when I pull up my calculator here, I have it all plugged in there. I put parentheses around my numerator. Don't forget to do things like that, right? Or use your alpha y equals. This doesn't have the fraction feature, so I had to type it in this way. I'm going to go to, let's see here. How about second table set? And how about I start at, I'll go with 2 for now. And let's go by, actually, you know what? Yeah, we'll start at 2. Let's go with, instead of auto, let's go with ask. Okay. Now let's go to my table. So how about this? Let's plug in a value that's on the left-hand side of negative 2. So how about negative 2.1? Hit enter. Okay. And let's get even closer. So negative 2.01. Okay. And how about negative 2. Let's go with 0.001, and let's see where we're at once we get there. Okay, so we're getting, it looks like a little closer to maybe we started at 22, then we were getting a little closer to 21. Let's go one more from this side, negative 2.0001. Okay, so even closer to 21 still. Now, I wonder if the same thing will occur on the left-hand side. I'm going to plug those values in while I pause it. All right, let's take a look here. We've got negative 1.999. That gives me 20.99. And then negative 1.99 gives me 20.9. So as you can see, I did them where I'd skip over negative 2. This was negative 2.0001, but it doesn't always show all that, right? It only goes so many digits there for us, okay? But again, it looks like we're coming up on that 21, but let's see what happens here. Let's just go, I'm going to replace one of these. What if I just did straight up negative 2? All right, let's just try it. I get an error. Okay, and that does make sense. As we said, hey, if I plug in negative 2, I'm going to be dividing by 0, so it should be undefined. I'd get an error. Let's fill in our table. All right, and there we go. So I put in just a couple of them there as we got closer to that negative 2, and we did have that undefined. But let's see, can we see what is it approaching there? It definitely appears that it is approaching from the left and from the right, f of x equaling 21. Okay, so the limit limit of f of x as x approaches negative 2 of this particular function would be 21. Cool. All right, so let's take a look here. So we have a few ways of finding those values on a calculator. The one we just did was the table of values. Now, not as accurate, but fast. Let's see what that means there. So remember how we were talking about how this one appeared to be just -2 here? It's because I ran out of decimals. But if I really hovered over it, it would give me something a little more accurate, right? And actually, if I arrow over to the right, I can actually see the full values here. Okay, I'm not full. That's not exactly always the full thing. It could go on forever, right? But I can see a more detailed, more digits there for me, so I can see a little more of what's going on if I were to arrow over and actually look at that and hover over it. So that's kind of nice. And that function notation will actually do the exact same thing. And I'm going to skip over the function notation for now, just because I think this will be enough for us here in this intro to limits. Okay, so the table works nice and fast. If you want a little bit more, you can arrow over them and you can click through them and see more decimals. All right, awesome. All right, now we got the function f is continuous and increasing for x is greater than or equal to 1. What the heck does that mean? Okay, well, that is saying that continuous just means it never, it never breaks, jumps, anything like that. It's continuous. Well, all right. Now, increasing means that it's always going up, right? The f of x, the output is always going up. It's increasing. So it wouldn't be, see, I have this like flat part here that shouldn't be there. So what it would be is just always going, it could be like that. It could just be a straight line. It could be very mild and then curve up, but never go flat or down. Okay? Now, why is that important here? Well, that would tell me that between these two values here, it's always going to be more. It's never going to dip down, right? I'm not going to get 4.84. Okay? So it does tell me a bit about that. So as I continue through, or anything greater than x is greater than or equal to 1, anything greater than 1 there, is going to give me an increasing value. I'm always going to go up. Okay, enough with that. Now, the table values, the table gives values of f at selected values of x. Approximate the value of the limit as x approaches 2 of cosine of f of x. What does that mean? Well, that's basically saying, let's calculate that limit of f of x as x approaches 2 and take the cosine of that. So what would we get for f of 2? Okay. Well, we don't know if we can exactly evaluate it, but we can use this table here. And it looks like x is going to be approaching 2 right in here. Well, what is my y value approaching? It looks like 5. So now what I can do is I can take the cosine of 5. All right, that's calculated right there. Now, we do want to make sure that when we plug this into our calculator that we are in the correct mode. So let's go to mode. I am in radian mode. That is the mode that we want to be in here. Okay, we want to be in radian mode. So now I just do the cosine of 5, and we are done. Now, in calculus, if you're going to be taking AP Calculus next year, this is just an introduction to limits, you will be using 3 decimal places, either rounded or truncated. That's a fun word, right? So rounded would be 0.284, and truncated would just be 0.283. So they would accept 0.284, that's your rounded, or 0.283, that's your truncated. Either one of those would be okay on an AP Calc exam. Okay? Cool. Awesome. Let's keep moving. Actually, I was thinking there was more, but that's it. Quick video. Awesome. Fantastic. I hope you guys enjoyed limits from tables. I know I did. Have a wonderful day, America. Freedom, rock and roll, Costco, Yo-Ro, and of course, Riverdog Jenny on the gram. All right. See you later.